In this video, we'll take a closer look at how to select the cofactor for a given chemical reaction. So what you want to do initially is identify what specific type of chemical reaction or chemistry is occurring. In this example, we see we're going from that alcohol on the left-hand side of the arrow to this oxidized carbonyl group on the right-hand side. So that is an oxidation reaction. Then what we'll do is we'll select from our known coenzymes. 8 of them or so are shown in this table for you. We know our coenzymes that can catalyze oxidation or redox reactions are our flavo coenzymes, FNM and FAD, as well as our NAD plus and NAD plus and NADP plus. This is a 2-electron transfer, so any of those 4 coenzymes would be acceptable. You'd likely just be given 1 or 2 correct responses. Since we're going in the oxidation direction, we'll just point this out. The correct coenzyme would be NAD plus. If you were to select NADH, the reduced form, that would be an incorrect response because what we're going to essentially do is transfer the equivalent of a hydride from our substrate onto the coenzyme. So really what we'll be doing in this process is our NAD plus will be converted into NADH. And that's the same for all of those options, the FN and FAD, NAD plus and NADP plus. All right, in our next example, we want to identify what's going on. This one's a little bit easier because you see the second product produced there is carbon dioxide, so that's a decarboxylation. Notice that that was present on our substrate, and then we've lost that and gone to an aldehyde. With this case, with this example, we only have one coenzyme that can catalyze that decarboxylation, and that's our TPP. This example, we're now also using some bicarb and ATP, so we got additional coenzymes present. This is doing the reverse of what we just looked at. We're adding that carboxyl group, or CO2, onto our substrate. So we had just a CH3 in our substrate. We now go to a CH2, CO2 minus. So that is an ATP-dependent carboxylation reaction. And again, we only have one coenzyme that can catalyze that type of reaction, which is biotin. Here we have an interesting reaction. So notice we have the same number of atoms on both sides. But what we've done is we've just basically rearranged from this branch chain substrate to a nice linear product, essentially inserting the CH2 between one of the carbon-carbon single bonds. So this is a molecular rearrangement reaction, and our coenzyme that can catalyze that is the 5-deoxyadenosylcobalamin. And now in our last example, we'll take a look at another kind of more unusual reaction. This time we already have a second coenzyme involved, the TPP. What we're going to do is transfer this hydroxyethyl group that's on TPP onto our CoA coenzyme to give us that acetylated CoA product. There is, again, just one coenzyme that can catalyze that, which is our lipoamide. All right, and that's going to wrap it up for this video.